So another thing that's important to think about when we talk about data is what we're trying to do with it. There are different types of studies. Your book summarizes them into essentially the idea of correlational and between group comparisons. And really what it comes down to is the difference of whether, when you're trying to think about what do these results really tell me, it comes down to whether you've done something that's observational in form or experimental in form. That's really the crux of the matter that we're going to get to here. You've probably heard correlation is not causation, right? And that's a great phrase everyone loves to throw out. And that's true. Correlation is only a piece of causation. To make a causal argument, you have to establish correlation, also called covariance, right? You have to show two things go together, right? Cause and effect go together. You have to establish temporal precedence. That is, you have to show that the cause comes before the effect, right? And you have to establish non-spuriousness, also called the exclusion of alternatives. You have to show that there was nothing that could have made the change in the outcome, in the effect, other than the cause. Otherwise, the cause may not have been a cause after all. So there's at least three criteria for causal arguments, right? Covariance, temporal precedence, and non-spuriousness. Now, to try to establish all three of those, the only way that really does that well is experimental work. In an experiment, you manipulate, that is, you control the independent variable, right? This is a good thing. So if I bring a bunch of people in and I randomly assign, true experiments use random. You don't get to pick, you have to let randomness do it because that's fair, right? Another thing about chaos, it's fair, right? Joker, totally true. I've thrown out a couple of Joker quotes, so you know I like that movie, right? But it's true, randomness is fair. It doesn't have bias, but you might have bias. You might like, oh, you seem really sick, let me put you on the drug. You can't do that, right? Several reasons, don't have time to go through all of them. Regression to the mean, right? Observer effects, all kinds of stuff. Can't do that. So if you want to make a causal argument, the best thing, and really the only thing that we can say you can do effectively at this point in time is a really well done experiment where you randomly assign people to conditions. So for example, you guys get placebo, you guys get the drug, right? And preferably you're going to do a bunch of other important things like really intense controls. You're going to blind people so they don't know what they're on. You're going to blind the evaluator so they don't know what drug the people are on. So like if a doctor's evaluating you for symptoms, if they know you're on the drug, that might bias them. So you blind them. That's called a double-blind study, right? Where neither the experimenter nor the participant knows their condition, right? Only some uninvolved third party does. So you might do blinding. You're going to do controls like making sure people don't vary other things systematically in their life. You don't want a bunch of people who all, do something at one time of the day and a bunch of people who do it at a different time of the day because, oh, that might be something that explains the difference that I want to cause. So you're going to try to control personal and situational factors other than the independent variable that you manipulate. So hopefully you remember this idea. Independent variable is a variable a researcher manipulates, right? That is, they choose who gets exposed to what levels of it, right? Like drug and placebo. Those are levels, right? Level 1, drug. Level 2, placebo. And I'm going to manipulate. I'm going to decide who gets what. And hopefully, right, in a true experiment, that's done with random process, not selection process. And hopefully we have a bunch of other things in place to prevent other potential confounds. We'll talk about that phrase more in a bit. Observational studies, there's no manipulation. If I just go out in the world and I say, hey, young people are on cell phones more than old people, I cannot infer that being young causes you to be on cell phones more. I can't do that. It's just an observational statement. It's a mere correlation. Now, there is a statistic called correlation, and what I don't want you to get confused is the idea that correlations never proves causation, but other statistics could. No, it is not a statistic that proves, right, the causal argument. Causal arguments are proved through methodological process, and a statistical relationship demonstrated through correlation or any other test is just one piece of that. You must critically appraise the process that went into the data collection. Was it experimental or not? Critical to be able to understand things like types of claims people make. Because three claims you're going to often see with statistics are frequency claims, which is simply how often stuff happens, association claims, which is the idea that two things just seem to go together, and causal claims, which are claims where people say X causes Y. right? Now, we love to jump to that X causes Y thing, but you can't do that unless someone's done a well-done experiment, right? There are continuum. We won't go into all these crazy designs that exist in research, but this is the important distinction I want you to get. Yes, it's true, correlation does not prove causation, but it is a critical component of it. So don't think that any statistic itself demonstrates a causal argument. You have to evaluate the method, okay? So there's a bunch of ways we can collect data in the world, and that also means different considerations for what we can think about or say about, right? So there are going to be limitations of self-report surveys, right? Like, did people tell the truth, is one students always say. But there's all kinds of other things much more nuanced than did they tell the truth, because a lot of times people do tell the truth as best they know it. The fact of the matter is, a lot of people have really poor insight into themselves. In fact, most people do, despite our protestations that we know ourselves well. We got a bunch of books. If you want to read them, just reach out to me. I'll send you some really cool links for books about some of this cool stuff, as well as studies like Nisbet and Wilson's classical article from the 1970s. So all kinds of stuff that, how you get your data also limits what you can say about it. There are limits in everything. We're human. The pursuit of knowledge is a process that is inherently limited by our own limitations. We aren't perfect. We don't know everything. We can't know everything. We do the best we can with what we have and acknowledge limitations. That is science. That is statistics, right? So using all these different types of things, observations, simulations, what you do to collect your data matters, right? That's the point I want to get across here. I don't need you to know every single one of these types of things.